Joy Abdurasa from grade 12 San Vitores. I performed this Labatum experiment last October 11, 2021. So my objectives are calculate the acceleration of a moving item depending on its position over time, and create a graph of the data which will be used to calculate the graph's acceleration and slope. And the materials are linear air trap, 2 GM weights, millisecond timer, and graph
Experimental setup, which was the link provided by our teacher, and we watched it. So I just took a screenshot of it for my experimental setup. That's my data and results for the and T average squared. So that is my data and results. This is my graph for the narrow side down, and the other one is the wide side down. So that's the graph, narrow side down.
Data analysis. According to the video, friction, balance, and the blower strength all impact the experiment's outcome. The holes in the truck affect the glider's movement for balance. The weights on the glider must be balanced. In this case, it should be balanced at 60 kg per side of the glider. And finally, for the strength of the blower. As stated in the video, the blower should be at full speed for the glider not to wobble and for accurate data to be obtained. The accuracy of charting the points was one of the obstacles I had when creating the graph. Obtaining the slope of the graph was similarly difficult because specific points had to be correct when compared to the wide side. The narrow side had speedier data. The intervals for the distance almost did not influence on the narrow side average time because it had a shorter time, whereas the broad side took a little longer for the glider to glide across the surface, resulting in slower data than the narrow side. The acceleration of the narrow side is greater than the wide side since acceleration changes with slope and slope vary with the graph. Based on the trial table, the narrow side already indicated that it takes less time to glide across the surface. As a result, the narrow side is larger than the wide side. Even if the acceleration value is negative, gravity continues to act on the object. If the item is vertical or perpendicular, it reflects the free fall acceleration of negative 9.8 meter per second squared. For my recommendations and conclusions, to sum up everything, I measured an object's acceleration depending on its position accurately, and as time passed, graphing the given data was also easy because the points corresponding to the table of trials provided. Friction, balance, and pressure are also crucial because they affect how the glider moves on the linear air track, which must be accurate so that no extraneous factors interfere with the object being evaluated. Thank you.